Forensic Science Lecture 11-3, Impact Blood Spatter Patterns. Impact spatter is the most common pattern that is found at crime scenes. It's produced when an object makes a forceful contact with a blood source and it projects the drops outward. There are two types: forward spatter, which is projected outward and away from the source, typically formed from exit wounds, and then backward spatter, which is projected back towards the source, potentially depositing blood onto the object or the person, creating the impact. A lot of times this occurs from an entrance wound. In classifying impact spatter, as the force of the impact increases, the velocity of the blood drops also increase, and this causes a decrease in the diameter of the droplets. So the higher the velocity, the smaller the droplets. There are three velocities of blood spatter: low velocity, medium velocity, and high velocity. With low velocity spatter, patterns consist of a large number of separate or compounded drops. The diameter is about 4 millimeters or more, normally produced by applied force of 5 feet per second. So it tends to be slower, droplets falling from an open wound, because it's normally produced by gravity or objects falling into a pool of blood. Medium velocity spatter consists mostly of small droplets, anywhere from 1 to 4 millimeters, with an applied force of 5 to 25 feet per second. This is normally associated with a blunt force trauma, like being hit with a bat or something of that sort, or even a fist. High velocity spatter, on the other hand, consists of a large number of very fine droplets or spray. The diameter is less than 1 millimeter, and the applied force is 100 feet per second or faster. So this is typically produced by a gunshot wound, exit wound, or an explosion. Using the size to classify the impact is useful in giving insight to a general nature of the crime, but it can't illuminate the specific events that produced the stain size pattern. In general, investigators should use stain size categories very cautiously, and for descriptive purposes only in evaluating impact spatter patterns. A more acceptable approach for classifying patterns should include observations of the stain size, shape, location, and distribution patterns. So again, not focusing on one aspect, but on many, to come up with the series of events. Impact spatter can help to determine the origin of the source, meaning the position of the victim at the time of impact. Investigators determine the origin using the area of convergence. This is an area of 2D plane where the droplets originated. It is established by drawing lines, straight lines, through the long axis of several blood stains following the line of their tails. Where they intersect is the area of convergence. Anytime that an object hits a source multiple times, they're never going to produce exactly the same pattern. So a number of impacts can be determined by drawing areas of convergence for groups of spatters. Kind of gives a better idea as to the series of events that took place. Another aspect of figuring out where the individual is the area of origin, and this is the area in a 3D space from which the blood was projected. Distribution of droplets in the pattern give a general area of distance from the source to the surface, and this shows the position of the victim and or the suspect in the space when the events took place. The most common method for determining area of origin is called the string method. Um, and so what they'll do is they'll find the area of convergence of the spatter. They'll then find the angle of impact for each of the droplets, place a pole or a stand at the axis in the area of convergence, and then attach one end of a string to each droplet. Using the protractor next to each droplet, they will lift the string until it lines up with the angle of impact, and then attach the other end of the string to the axis pole. And then where the strings meet is where they would or which would indicate the area of origin. This ends lecture 11-3. There is a quiz next class.